Here we go. Okay, this is Honors Chemistry, Chapter 3, Test Hints, Part 2, 21 through 40. You'll have to watch the first half of the video. They're mocking me. You have to watch the first half of the video on Moodle to get the other part. Here we go. Alrighty, number 21. Deuterium, protium, tritium. Protium, deuterium, tritium. What is different? Well, what element are protium, deuterium, and tritium?
1, 2, 3.
Hydrogen. Hydrogen. They're hydrogen with a mass of 1, hydrogen with a mass of 2, and hydrogen with a mass of 3. Protium, deuterium, tritium. Okay? What is different about them?
1, 2, 3.
Yes, but why are they 1, 2, 3? The what? The neutrons, the number of neutrons. How many does protium have?
1.
How many neutrons does protium have? How many neutrons? 0. Its mass of 1 comes from its 1 proton. Okay, deuterium has how many neutrons? 1. And tritium has how many neutrons?
4. 1. 2.
2. How many protons do they all have? 1, because it is hydrogen, and that's what makes it hydrogen. Okay. Number 22. How to differentiate specific isotopes. So specific isotopes, like how would we write, well, what's another way to write the 3 isotopes of hydrogen? This is the nuclear symbol way. What's the other way? Crickets. H1,
H2, H3.
H2, H3. And sometimes you see it with the name written out, like uranium-238. So we know it's the element uranium, and it happens to be the uranium that has a mass of 238, that isotope. Okay? Notice that the mass number here is a whole number. It's not average atomic mass. The numbers on the periodic table are average atomic mass. This is a specific isotope. Each of these is a specific isotope. So they're going to have a mass number that's a whole number, which I hope is another test hint coming up. 23. What the atomic number of an atom represents. So it's kind of like the definition of atomic number. And if I said an element has an atomic number of 12, that means it has 12 what? Protons. And what element is it? No.
Magnesium.
Magnesium. The atomic number is 12, not the mass. The atomic number. The atomic number is the number of protons. 24. What happens to the numbers of protons and neutrons in a nucleus as the mass number changes? So here we have, with our hydrogen isotope, the mass number changing. What is happening to the number of protons in the nucleus? Nothing. That is staying the same. And what is happening to the neutrons? They're increasing, right? Yep.
Wait, so those numbers on the top, those are the number of neutrons?
Not exactly. It's the mass number, which is protons and neutrons together. And the bottom one is the atomic number, which is just protons. Okay, this is what that quiz was about. Atomic number, mass number quiz. Remember that? With all the boxes? Yes.
How do you know how many electrons there are?
Oh, how do you know how many electrons there are? Electrons have to match the protons. Okay? Electrons have to match the protons. These are different isotopes, and I've seen in answers to things that people are giving me that some of you are mixing up isotopes and ions. Ions can change the charge, which would be because of the number of electrons. Isotopes are changing just the mass. Yep.
Can it be an isotope and
Yes, it can. So we could take away some of the an electron from these and have an ion of deuterium. All right, 25. The standard of atomic mass. What isotope, what exact isotope do we use to compare all of the other elements on the periodic table to? Carbon 12. What are two ways to write that? C12, or we could spell it out, or we could write C with a 12 on the top and 6 on the bottom. Okay? That isotope is the standard. Even if the other answer choices mention other isotopes that used to be the standard, right now, carbon 12 is the standard. 26. How is average atomic mass calculated? Now, you're not actually going to have to calculate average atomic mass in this question. You'll probably have to do that in another question. But in general, what do we need to know in order to calculate the average atomic mass, say, of these 3 isotopes? There are more for carbon, but we'll limit it to just 3. Yep. You need to know the percent abundance. And what else?
The mole.
The actual mass of the isotope. So the mass of each one. And we take the percent abundance times the mass of the isotope, we add them all up. This is what we did with the big books. Yeah.
What is the percent abundance?
The percent abundance is how much of all, say, carbon that's naturally occurring is made of carbon 12. And how much of it is carbon 13, and how much of it is carbon 14. And nobody memorizes that. We all go and look in the CRC handbook to figure out what those values are. Because scientists, long before us, have actually done experiments and figured it out experimentally. Okay? Yep.
So we won't need for the test, like, percent abundance.
Oh, if I ask you to calculate the average mass of an isotope, I'll give you the percent abundance. Okay? 27. How to find mass number when given the number of protons, neutrons, and electrons. Here is an example. An atom of, an isotope of nitrogen has 7 protons, 7 neutrons, 7 electrons. What is its mass number?
17.
I'm glad you said that. It is not 7.